All right, let's dive deep into some space science today.
Yeah.
We're going to be tackling the SMILE mission,
Oh,
but we're going way beyond the basics on this one.
Okay.
This deep dive is for the people who really want to understand the nuts and bolts.
okay.
We're talking about cutting-edge technology, that's designed to help us unlock the secrets of Earth's magnetosphere,
Right. Yeah.
that invisible shield that protects us from the sun's, kind of chaotic behavior sometimes.
Absolutely. And what's really exciting about this mission is the international collaboration.
Yeah.
The European Space Agency and the Chinese Academy of Sciences have teamed up to bring together their expertise
Right.
and create something really groundbreaking.
Our listeners are no strangers to space science, so
Yeah.
let's just jump into the heart of this.
Okay.
What problem is SMILE specifically trying to solve?
Right.
We know that the sun throws these massive bursts of plasma our way,
Yeah.
coronal mass ejections,
Yeah.
but we often kind of lose Earth.
Right. It's like we can see the pitch coming, but not where it lands.
Yeah.
And those CMEs, they interact with our magnetosphere.
Right.
And those interactions dictate space weather.
Oh, okay.
And that's really the key, because understanding those interactions is critical
Right.
for protecting satellites and communication systems and even here on Earth.
Wow.
And SMILE's mission is to bridge that observational gap.
Okay.
It's giving us this continuous view of these solar storms from the moment they leave the sun until they reach Earth.
So it's like we're finally getting a complete picture of the game and not just like scattered highlights.
Precise.
And to do this, SMILE is taking a approach, right?
It is, yeah.
This is the first mission to use two different types of imagers
Right.
to visualize the entire magnetosphere.
Yes.
We're talking X-ray imaging, which I think is a huge technical feat,
Yeah.
combined with ultraviolet observations.
Yeah.
This is going to give scientists a much more comprehensive view than we've ever had before. This is going to give scientists a much more comprehensive view than we've ever had before.
It is, yeah.
Imagine, like, trying to understand a complex machine by only looking at a few of its parts.
Right.
SMILE is giving us the blueprint.
Yeah.
It's showing us how all these pieces fit together
Yeah,
and
yeah.
how they interact.
That's a great analogy.
Okay,
Yeah.
so zoom in on those individual parts for a moment.
Okay.
SMILE has 4 scientific instruments,
Right.
each with a specific role to play.
Okay.
The first one is the light ion analyzer.
All right.
What's its job in this cosmic orchestra?
Well, this instrument acts like a detective, analyzing the plasma surrounding the spacecraft.
Oh, wow.
It differentiates their density and their velocity.
Okay.
This is really crucial for determining the composition of the solar wind and how it's impacting the magnetosphere
Okay.
at any given time.
Gotcha.
Imagine it like analyzing fingerprints left behind at a crime scene.
Right.
The light ion analyzer is deciphering clues hidden within the solar wind.
Wow.
It's revealing the story of its journey from the sun to the Earth.
Okay, so we've got our plasma detective on board.
We do.
Next, we have the magnetometer.
Right.
I hear this one involves a rather impressive appendage.
It does, yeah.
The magnetometer uses this 3-meter boom that deploys once SMILE is in orbit.
Right.
It acts as like a sensitive antenna.
Yeah.
It allows the instrument to measure the magnetic field around the spacecraft.
Yeah.
And these measurements are super vital
Absolutely.
for understanding the structure and the dynamics of the magnetosphere.
Yeah.
Like a 3D turning in response to the solar wind's pressure.
Yeah.
So it's like SMILE is mapping out the invisible architecture of the magnetosphere.
It is.
It's revealing its hidden framework.
Yeah.
Now let's talk about the heavy hitters.
Okay.
The imagers. First, the soft X-ray imager,
Okay.
which sounds like something straight out of a sci-fi movie.
Yeah. Yeah. It's pretty close.
Imaging X-rays in space.
Yeah.
Incredibly challenging.
It is.
But the payoff is enormous.
Absolutely.
This imager is going to capture the X-rays that are emitted
Right.
when the solar wind slams into the magnetosphere.
Yeah.
It's like capturing this cosmic fireworks display,
Right.
where bursts of points of impact
Mhm.
and the energy transfer
Yeah.
that's happening between the solar wind and Earth's magnetic field.
Yeah.
Scientists are going to be able to study those CMEs in action.
They are. Yeah.
We'll see how they distort and mold the magnetosphere shape.
Absolutely.
It's like we're finally getting a front row seat to this cosmic ballet.
We are.
And last but not least, we have the ultraviolet imager.
Okay.
This one is focused on something a little bit closer to home, right?
It is. Yeah.
The ultraviolet imager is going to be observing the auroras.
Right.
You know, the stunning displays of light we see at Earth's poles?
Yeah.
But what's interesting is that it can observe these on the day side of the Earth, which is normally impossible because of the glare.
It is.
How does it manage to do that?
Yeah. Well, it uses specialized filters that block out the overwhelming brightness of the Earth's day glow.
Oh, wow.
Which allows it to capture those subtle auroral emissions, even on the sunlit side.
Okay.
And it will give us this continuous view of how energy from the solar wind is being transferred into our atmosphere and creates these beautiful displays.
So it's like SMILE is peering through the curtain of daylight.
Yes.
To reveal the hidden auroral show that's going on behind the scenes.
Yeah.
Each of these instruments, I think, is super impressive in its own right.
They are.
But what really strikes me is how they work to create this unprecedented global view of the magnetosphere.
Exactly.
But to get that perspective, SMILE needs to be in a very specific orbit.
It does, yeah.
Most Earth-observing satellites stick to much lower orbits,
Right.
circling the planet several times a day
Yeah.
to get like a good detailed view.
Yeah.
But maybe that misses the bigger picture.
Exactly, yeah.
SMILE needs to reach an altitude of 130,000 kilometers above the Earth's pole.
That's right.
This highly elliptical orbit is key.
Yeah. So before the break, we were talking about how SMILE's unique orbit is crucial to its mission.
Right, because most Earth-observing satellites, they stick to much lower orbits.
Right.
They circle a planet many times a day.
Yeah.
And that gives them a great detailed view.
Yeah.
But I guess that maybe they missed the bigger picture.
Exactly.
Those lower orbits are great for specific regions.
Right.
But they kind of limit the ability to see how the entire magnetosphere responds to the sun's activity.
Yeah, think of it this way. If you're standing right next to a tree, you can see the details of the bark and the leaves, but you miss the overall shape and how it fits into the forest.
Okay, so SMILE's highly elliptical orbit, taking it 130,000 kilometers out, is like taking us back to appreciate that whole forest.
Exactly.
It's getting that wide-angle lens perspective on the magnetosphere.
Precisely.
That distance allows SMILE to see how the entire magnetosphere, as like a single interconnected system, reacts to the pressure of the solar wind.
Yeah.
And those bursts of energy from the CMEs.
Yeah, it's like watching. You need that broader view to understand the full impact.
And that kind of data, combined with the observations from those 4 instruments, is going to give scientists a whole new understanding of space weather.
Absolutely. We're talking about potentially being able to forecast space weather events with a level of accuracy we've never had before.
Right now, it seems like our best predictions are like, oh, there might be a solar storm this week.
Yeah.
Being able to predict these events with more precision, knowing when and where they'll hit, how strong they'll be.
Exactly.
That would be incredible.
It would transform how we operate in space.
Yeah.
Imagine being able to proactively adjust satellite orbits to avoid the most intense radiation.
Wow.
Or giving power grid operators time to implement safeguards. To prevent these widespread outages.
Yeah, it's all about mitigating risk.
Exactly.
Not just for big systems. But even astronauts on the International Space Station. Knowing when a solar storm is coming could be the difference between, routine operations and having to take shelter.
Absolutely.
And those heavily shielded modules.
Exactly. And all of this is made possible by that collaboration between ESA and CAS. It's truly remarkable to see what can be achieved when scientists from different countries put their heads together. Combine their expertise to create something like this.
It's easy to get caught up in the technical details. But I think it's important to remember the human element of all of this. This collaboration, it's a testament to our shared curiosity and our drive to understand the universe around us.
I agree with
I
agree with that. Yeah.
No matter where we come from.
I completely agree. This mission highlights the power of science to transcend political boundaries and bring people together in pursuit of a common goal.
And it's not just about the scientists and the engineers.
That's not.
Think of all the support staff, the data analysts, Earth, to receive and process all that data.
Exactly. It's a global effort.
It is.
The truest sense.
The SMILE is going to be sending back a fire hose of information.
It is,
Terabytes upon terabytes of observations from these 4 instruments.
Absolutely right. And that's another exciting aspect of this mission, the data analysis challenge.
Okay.
It's not just about collecting the data, it's about making sense of it. It's finding the patterns and extracting those meaningful insights.
So this is where the real detective work begins.
It is.
I know we have these sophisticated algorithms now and machine learning techniques that can sift through mountains of data. But it still takes that human intuition and expertise to connect the dots.
Yeah.
And make those groundbreaking discoveries.
It does. It's that blend of cutting-edge technology and human intellect.
Yeah.
And with a mission as ambitious as SMILE, I have no doubt there will be plenty of surprises along the way.
Oh, for sure.
We might discover new types of auroral displays, might uncover hidden structures within the magnetosphere,
Right.
or even find these unexpected links between solar activity and Earth's climate.
That's what gets me excited, those aha moments that make it all worthwhile.
Right.
So with all this data pouring in, what are the chances that SMILE's going to uncover something that we never even anticipated?
The chances are high.
Wow.
Every time we send a mission to explore something new,
Yeah.
we inevitably find things we never expected.
Right.
It's like venturing into uncharted territory. You're bound to stumble upon those hidden treasures.
So it's not just about answering the questions we already have.
It's not, no.
It's about opening these doors to new questions.
Right.
New avenues of inquiry that we hadn't even considered before.
Exactly. And those unexpected discoveries often lead to the most profound shifts in our understanding of the universe.
Wow.
They challenge our assumptions.
Right.
They force us to rethink our models, and they ultimately drive us to explore even further.
That's the beauty of science. Never-ending journey of exploration and discovery.
Yeah, it is.
And with missions like SMILE, we're constantly pushing the boundaries of what we know and what's possible.
Indeed, it's like we're peeling back the layers of an infinite onion.
Right.
Revealing new complexities and wonders with every layer we remove.
Yeah.
And that brings us to another fascinating aspect of this mission.
Okay.
The challenge of visualizing this complex and dynamic system.
How do you make the invisible visible?
Yeah, it's a fascinating challenge.
Right.
Scientists are using a variety of techniques to translate the data from SMILE's instruments. Right.
Into something that we can actually see and comprehend.
Okay.
So they're creating these 3D models of the magnetosphere.
Okay.
They're mapping out the magnetic field lines.
Right.
And even animating the interactions between the solar wind and Earth's magnetic field.
So it's like turning raw data into a cosmic movie.
It is.
We can actually visualize this invisible dance that's happening all around our planet.
Exactly, yeah.
I imagine it's also a great way to communicate those findings to the public.
Absolutely. These visualizations are crucial for sharing the excitement of discovery.
Yeah.
For making the science accessible to everyone.
Right.
They help us appreciate the beauty and the complexity of the universe we inhabit.
Right.
And they inspire us to keep exploring, keep asking questions.
Yeah.
And to keep pushing the boundaries of human knowledge.
I love that. And speaking of pushing boundaries,
yeah,
there's one aspect of SMILE that I think is particularly relevant to our listeners.
Who really appreciate the finer details of space exploration.
I'm intrigued. What aspect are you referring to?
The challenges.
Because
sending a spacecraft 130,000 kilometers out into space,
right,
equipping it with these incredibly sensitive instruments,
yeah,
then coordinating a global team to analyze the data.
Yeah.
It's no walk in the park.
It's not, no.
There are bound to be hurdles along the way.
Absolutely.
SMILE instruments calibrated and operating perfectly in that harsh environment of space is no easy feat.
You're right. The extreme temperatures, the radiation, and the vacuum of space can wreak havoc on delicate instruments.
Wow.
The engineers who designed and built SMILE's instruments had to account for all these factors to make sure they could withstand the rigors of space travel and continue to operate reliably for the duration of the mission.
And then there's the challenge of managing and processing all of that data.
There is.
We're talking about a potential deluge of information coming back.
It is. It's like searching for a needle in a cosmic haystack.
Right. So it's not just about building the spacecraft and launching it.
Right.
It's about creating that infrastructure here on Earth.
Yeah.
To handle that scientific bounty that SMILE's going to bring back.
Precisely.
That involves not just computing power and storage capacity, but also the human expertise to interpret the data.
Yeah.
To make those connections.
Right.
And translate the findings into actionable knowledge.
Exactly. And that brings us back to the collaborative nature of this mission.
Yeah.
It's not just about the technology. It's about the people behind it, the scientists and engineers working together across borders to advance our understanding of the universe.
It's a testament to the It's a testament to the power of human curiosity and our desire to explore the unknown.
It is.
And who knows what incredible discoveries await us.
Right.
Well, that's the exciting part. We've covered a lot of ground.
We have.
From the technical intricacies of the mission to the broader implications of its final.
But I think there's like a bigger question we haven't addressed.
Yeah, I agree. We've covered the what and the how.
Right.
But now we need to talk about the why.
Exactly. Why is this mission so important?
Yeah.
What are the long-term implications of what SMILE might uncover?
Right.
We've talked about things like improved space weather forecasting.
Right.
But I feel like there's a deeper layer. Space weather forecasting.
Right.
But I feel like there's a deeper layer here.
Yeah, I think you're right on a fundamental level. SMILE's pushing the boundaries of our understanding of the Sun-Earth connection.
Okay.
It's giving us this new perspective on this intricate dance between our star and our planet.
Right.
It's revealing the invisible forces beyond protecting satellites and power grids.
Right.
It's about gaining like a deeper appreciation for our place in the cosmos.
It is.
Recognizing that we're not just isolated on this little blue planet.
Right.
But that we're actually part of this vast and interconnected system.
Absolutely. SMILE showing us that Earth's magnetosphere isn't just this static shield.
Right.
It's this dynamic and ever-changing region that responds to the sun's every whim.
So it's like a living organism constantly adapting to the forces around it.
Exactly.
And just like with any living organism, understanding its behavior is crucial for its well-being.
Yeah.
And the more we learn about the magnetosphere, the better equipped we'll be to protect it.
Yeah.
And ourselves.
Yeah.
From the sun's sometimes harsh outbursts.
Absolutely. And it's not just about protection.
Right.
Understanding the Sun-Earth connection is also about unlocking the secrets of our own planet's history. Scientists believe that the magnetosphere has played this crucial role in shaping Earth's climate and even the evolution of life.
So we're talking about potentially rewriting the textbooks on Earth history based on what SMILE discovers.
It's a possibility.
Why?
And let's not forget about the potential for unexpected discovery, even Pluto.
Yeah.
We find things that surprise us, that challenge our assumptions,
right,
and open up these new avenues of inquiry.
So who knows what mysteries SMILE might unveil about our own backyard?
Exactly. We might discover new types of auroral displays.
Okay.
Or find evidence of these previously unknown interactions between the magnetosphere and Earth's atmosphere.
It's like we're finally starting to appreciate the true complexity of our own planetary system.
Yeah, we are.
And I think that's what makes SMILE so exciting.
It is.
It's not just about answering the questions we already have.
Right.
It's about opening our minds to new possibilities, new ways of seeing our place in the universe.
It's about
It's
about embracing the unknown.
Right.
Recognizing that there's still so much we don't know and being open to the surprises that await us as we continue to explore. Yeah. And that spirit of exploration, that thirst for knowledge.
Yeah.
That's what drives us forward as a species.
That's what makes us think it's time to bring our deep dive to a close.
It has been a really enlightening journey.
To our listeners, thank you so much for joining us on this exploration of the SMILE mission.
Yes, thank you.
I hope you've gained a new appreciation for the science, the technology, and the human spirit that drives us to push the boundaries of what we know.
Absolutely.
You too, keep looking up.
Yes.
Keep asking questions.
Yeah.
And never lose that sense of wonder that makes exploration so rewarding.
Agreed.
Until next